what you want to know, because it's sort of an open session. I have a lot of information, but it would help me focus on what we call in Intel a user experience engineer. So what does that mean? So Intel, as you probably appreciate, apart from processors and other pieces or components like that, don't really make end user systems. However, we are what's called an ingredient brand. So you'll see Intel inside in various devices like, a Lenovo tablet, laptop, what have you, right? So what does that mean for us? Why is Intel concerned about how the end user perceives our product? Well, it's quite simple. We do a lot of work in the background to make sure that the quality and the actual systems that are produced by our partners meet the sort of demands of the modern consumer. Okay, so that's a very important thing to us, and we have a lot of engineering work in the background that does a lot more than just make chips. Okay, so for instance, take for instance the USB bus. Okay, that's something you use every day on non-Intel devices as well as Intel devices. Okay, that was invented by Intel to make things easier to connect. So make a universal serial port. That's what it stands for. Serial bus. Sorry, that's what USB stands for. So that was an Intel invention. But Intel then gave that IP away for free, so that others would start using it. So it became a standard. PCI Express, PCI. These are all examples of the sort of innovations that Intel's brought to market internally. Now we're looking at, okay, well, what about end user devices? People like tablets, people like end user type machines, ultrabooks, thinner light laptops. Where's this going? And then on the desktop side, we've got, you can build super powerful desktops in small form factors, or you can just make ridiculously powerful desktops in massive form factors, So you have all of this scope and ability to fine tune what you need. The problem with choice comes complexity, right? So hopefully the stuff that you do helps end users work out what they want, right? Because they have a budget, they have to, they think they know what they want to do, but they might see something that you do that inspires them, right? So, and this is why it's important to us to explain to you, and hopefully then you to carry the sort of a torch on to the end users, the sort of thing that we want to sort of get forward. So that sort of explains my role in a very long-winded way, and I don't just deal with high-end desktops. There's all-in-ones, there's tablets, there's phones, there's ultrabooks, there's laptops, you name it. Pretty much anything on the consumer spectrum I deal with. I just don't deal with business stuff and servers, and they're a complex beast all by themselves, right? That's an interesting topic if there was one. And now we're getting into what we call Internet of Things. So as part of this room, one of the other teams who uses this, there's an Intel Quark over there, but it's like Intel's smallest processor. And that is used for embedded devices, and essentially the creativity that people can put computing devices into now is almost limitless. So it's a very exciting time to be not just using computers, in your day-to-day life, but also to expand how those computers interact with you. So we're on the verge of some great stuff. Okay, there you go. So, who are you, and what's your perspective on what do you want to know? I'll start with you and go around.
I'm Hal Thompson. I review for Haltech TV, as the rest of these guys know. Basically, what I aim to do is obviously review as many products as I can, but from Intel's perspective, is your kind of goal to bring as many products and as much choice out as you can, or is it more about, say for example, bringing a smaller selection but over, say, a wider range? So say for example, mobile processors and desktop processors, but maybe expanding into other areas, or are you more focused on expanding in say smaller desktop market?
We're interested in anything the silicon can go into, okay? Which answers all your questions at the same time, but none of them at once, right? Yeah, so you might not be aware, but Intel's already in a lot of things. And a lot of our current mobile processors and desktop processors, there's even a Xeon in an HP printer, right? So, but there was what we called the embedded side of the business, which was quite literally, it's what it sounds. You put a computer, effectively, maybe a bespoke computer, inside some specialist equipment.
Yeah, we've got a microserver from HP that I believe has an Intel embedded processor. Which one is it? I think it's a Celeron. So yeah, we've got.
So some of these specialist embedded processors, actually, the reason why they're specialist embedded processor is they have a 7 or 10 year guaranteed lifespan. So because you don't want to be swapping out something that you rely on every day, right? We're in cars, we're in all sorts of things, infotainment, as well as some of our older chips are actually in like the sort of onboard control systems, like the brake system and stuff like that. So there's already a lot of Intel technology probably that you aren't even aware that's there. But yeah, we're making it more public, as in going big on the Internet of Things. We're going big on tablets as well, but we're not forgetting the traditional desktop PC user, okay? Because that's still the best compute experience you're going to have, okay? So, tablet's great, nice little mobile thing, fits in your pocket. As long as it's not one of these massive 10-inch ones, and it's got really big pockets, obviously. But yeah, if you've got a desktop PC as well, they're a good complement. You've got something in between, like a mobile, and then you've got potentially all these other devices going to connect to it. You could potentially all these new things coming out, like the sort of home control type systems. You talk about a microserver. The list is almost endless. So Intel just wants to make silicon which will enable any of these use cases. And if there's a use case to be had, we will design a chip accordingly. So basically, your imagination and our factory is potentially where the product line will go. I think there's more demand for computing power, and it builds on itself, so there will never be enough,
Phil? Yeah. So I'm Phil Christie. I'm with Tom and Andrew for Tech Team Dewey. We basically make reviews, unboxings, tutorials. Basically, we cover the whole wide spectrum of technology. Personally, I'm quite interested in Intel's role that it has to play in the smartphone market, because obviously the major players now, you've got ARM, different kind of Snapdragon, Apple's own processors. I'm just interested to see where Intel's really going to go with that, because at the moment they're not huge players. I know they have got some phones out, but it's interesting to see, are they going to try and, because I know that the years back when Apple went from PowerPC to Intel, I wonder if a similar deal might be possible, or coming up in the future, because I know Apple are quite big on their own processors, but it's not out of the question that they might go through Intel.
I don't know any of the product specifics.
Yeah.
I'm not sort of in that commercial side at all. What I can tell you is there are already phones with Intel processors out there. So Asus announced a lot at CES, and they've actually just started bringing their Zen phones and other phones to market. They've already had, I've got one over there somewhere, it's a 6-inch they call it the phone pad note or something like that. And that's been around since December. And there's the PhonePad 7, which has been around a long time, and for a little while that was the cheapest smartphone you could buy, and you could buy it on Amazon or wherever for around about £150. So Intel has presence in the market. As for what you just asked. You say ARM, but ARM is a designer of architecture. They then license the architecture out to other vendors who then design it into their chip, who then get another manufacturing company to make it for them, okay? So that's how it works. Whereas Intel, we can design our own chips and then we make them ourselves. And our process technology is ahead of all the competitors, and we're about to go to 14 nanometers, which is way ahead of all the competitors, okay? But we did announce a deal with Rockchip, which is on the web, and so look at the details on that, which we've licensed our processor technology to those guys. So they've basically taken that ARM core out and put an Intel core in. So it means that potentially Rockchip-based systems, so lower cost tablets, smartphones, what have you, will actually have Intel processors inside.
Right, can we go next? I can do. I don't actually present anything. I work with Hal. You mentioned the Internet of Things. One of the things I'm interested in that could perhaps relate to that somewhere in the future is home automation. And it sounds like a fantasy, but when you watch like sci-fi movies, everything's integrated. The walls have eyes, everything's done for you. What's Intel doing to kind of move into that market, or is it just not?
It's an interesting thing, because this room 10 years ago when we first set it up, we had a whole bunch of home automation stuff. We had, you can still see some cameras around, and even that blind moves up and down with the faux picture of the sheep on it. This was all controlled via what we had, a media center at the time. I don't know if you guys ever came across media centers or know about existence, okay? And so it was all done through a home PC effectively. And we worked with a few specialist companies who had the Z-Wave and other sort of architectures, I think Domia was their name, that had these controllers set around the home. So it's not a new idea. However, these devices were relatively dumb, and that is the change. So the Internet of Things brings intelligence to these devices, so it allows them to connect and almost be their own entity, and that's where the compute power that you now have in even the smallest, the core processor is basically a very, very fast sort of Pentium processor, right? Sort of 400 megahertz, and that's our lowest processor. So you can then put others in there as well. It's not just about the hardware though. So you have to remember that what I said earlier about Intel brought a lot of standards to the market. Also, it's about the software. So we have something called Wind River, which is a sort of it's a software acquisition that Intel made a long time ago, and they make a hardened version of Linux. Because what you don't want is, because the problem is all your devices are on the internet, you don't want someone hacking your house, right? So they make a very hardened version of Linux that is bulletproof and will stop people getting in there. And then it goes through several layers. For instance, there's a green box around the corner which has sort of one of our router chips. I didn't know, but you didn't know that Intel has a router chip. And this runs Wind River on it and gives you one level of sort of security, and then all your devices connected to it have their own security on as well, right? So you have multiple levels of security in the house to stop outsiders sort of breaking into your networks. So yeah, imagine the disaster if you had a home automation system and a hacker got in there and was doing all sorts of interesting things with the walls that can see, right? So don't want to go down that route.
Yeah, that one.
Do you think it'd be a challenge getting companies to work together if that became like a reality?
No. So Intel's quite good at bringing consortiums of even competing companies together. Benchmarking being one example where competing companies agree on a standard of benchmarks, let's say. But also other things like, for instance, HDMI adoption. That was another thing. DisplayPort, stuff like that. Other technologies which are a good idea in the lab and then you take them out and you say, okay, well here is a solution. Now everybody, you know, work together to make it sort of a reality that then everyone uses on a day-to-day basis.
Thank you.
Right, shall I go next?
Yeah.
I'm Tom from Tech Team GB. So like Phil said, we sort of test sort of quite a wide spectrum of different sort of technology elements, from like sort of tablets to smartphones, sort of high-end PC hardware. Some of the main things that I'd like to cover, I think you have the Intel NUCs, you have the small sort of media PCs
Yes.
with the
David
Iris
is the,
graphics.
So the Iris graphics
Yeah, the
is
Iris
not
Pro.
in the Intel look. It's
Oh, is it
in
not?
Iris Pro is in the Gigabyte Bricks, which
the one
is
Bricks Pro, right.
a product that we work with Gigabyte on.
Right.
So it's not really a competing product, it's a
Yeah.
different sort of market segment.
Yeah, and obviously we'd quite like to test some of the high-end hardware. Things like your Intel SSDs as well. We'd quite like to give them a test down and
There
sort
you
of have a
go.
look at overclocking. Yeah.
There's a pair of 480 gig 730s on each one of these rigs.
Are they running in RAID or?
Running RAID 0.
Let's hope the radar array doesn't fail. I've had that a few times.
Right. I think that's.
Well, I guess me then. I'm Andrew McDonald from Tech Team GB. As has been explained twice already, we do basically PC hardware and consumer electronics reviews. We try and do the best content we possibly can. Obviously, we're fairly small, so we've got what we can, and we use cameras that sort of aren't the best, but we make use of what we have, and we do as many we try and get in touch with as many companies as we can, and obviously it's amazing to be here at an event like this, where we get to talk to both Intel and Asus, Gigabyte, MSI, the people who are actually making these parts, and it's also great to just say hello to people that you've been talking to on email for a while. I guess my question would be, because you're sort of an experienced engineer, over the last few generations of products in the CPU lineup, the performance-wise for things like, obviously we focus on gaming and stuff like that because that's what the end user is looking at.
Yep.
How many FPS can I get out of this or whatever. What are you looking at in terms of sort of performance improvements in the sort of further generations? Because over the last couple of generations it has been very sort of minimal. I know that games are moving off the CPU onto more GPU bound as opposed to CPU bound, but is there anything that you guys could do more towards helping sort of end user get a little bit more FPS for their money?
That's an interesting question. So I'm not sure. All I do know is Intel works very hard with the game industry to optimize the games, not just for CPU performance, but also the built-in graphics performance.
Yeah.
About 50% of all end users game on Intel graphics. I bet you didn't know that. If you look at the Steam survey. And so that means that it's actually quite an important value proposition to have optimized drivers, optimized and optimized games as well. So Intel does spend a lot of time and energy with the gaming industry to make sure we optimize the experience, as I said. Going forward, I'm not sure what we've disclosed in that case, so I will leave that to Anna as to regards our design decisions, but yeah.
Okay.
All I can say is obviously we are also in devices like this, and we will offer great graphics and sort of CPU performance, and the best in class in a device this size or slightly bigger. And going forward, that trend will then ripple to the other products.
Awesome, thank you.
Okay,
Sorry,
no question.
I've got a few more questions. Trying to figure out how to phrase it. I mean, obviously, like desktop PCs, the gaming market has expanded, but overall, desktop PC sales are kind of shrinking. And I've kind of got frustrated in the past because if you walk into like a PC World or another computer retailer, you walk past all of these tablets and these thinner than ever laptops, and then you get to the desktop PCs, which are same size, the same old form factor, same old look, and that's not really changed too much from the consumer perspective
I don't really have a
over the
specialist
past like decades.
details in that.
Well, I was going to ask because obviously you're releasing your Nux, or is it Nukes? How do you pronounce that?
Any way you like. It's next unit computing it stands for. So,
And the
yeah.
the gigabyte bricks. Do you think that's going to kind of revive interest in the desktop market?
So and I think we've publicly announced this, that there are basically 4 areas of desktop. So what we call the desktop market used to be the old beige tower, and it sort of changed colour to black, right? And that was pretty much it. But what's happened in that market? Well, we've got a rise of the mini PCs, okay, so the Nux, the bricks, that sort of thing, okay. And the Zotac have the Z box, and then the Zeus have the EPC, and then you name it. Where most of the guys who sort of make motherboards have like a miniature system, all in ones. I didn't have any here, but this is actually a really important thing. So Intel worked with the industry to make essentially what is a giant tablet, okay, but it's also a desktop PC. So we have an all-in-one which is always plugged in and is essentially, a desktop PC, but also we have what we call portable all-in-ones, which effectively have a battery in them. And even, I don't know if you've seen the 27-inch Lenovo Horizon, that you can put 2 batteries in, right? I have an optional extra, but you plug them in the bottom of it, and that gives you, say, 4 or so hours of battery life, and it's got a totally flat screen surface and it's touchscreen, and you can lay it flat on the table. Great for Christmas, got a family round, you want to play a bit of Monopoly, but lost all the bits on your board, or the dog ran off with the money or something. So what do? You've got it on your giant 27-inch portable all-in-one, right? And 4 hours is long enough before Family Feud starts. So the battery life will last way longer than the
Game will.
the game. So yeah, exactly. And this is sort of thing. This is a sort of another innovation, and trend that's brought to market. And consumer, especially ones for young children, they find this extremely useful for education, other things, and the kids just straight away get into it. Then we've got the enthusiast market, which is sort of what we've got here, right? So, hardcore gaming, people who just want the best PC, not just gamers. Often people who play games are often very creative as well. So, you don't just want to, you let off steam playing a game, but what you do in your spare time, well, you can obviously do video editing and stuff like that, but, a bit more gaming. Maybe you design some characters and stuff like that, or even just boring stuff on Excel, right? Working out how much money you got to spend on games, right? And hardware. So you've got all of this other activity that goes on the PC, and your desktop PC is a great platform to do that. Especially, the big towers are useful in some respects because there's a certain security aspect having a massive system that someone can't take out your window. So there's that aspect. And then you've got all the other stuff like backups and microservers and all the other stuff you might have in your house if you're sort of a super enthusiast. So really what you were talking about the sort of boring low-end towers, that market is sort of has basically changed into the others. There's still a market for that. If someone wants a sort of cheap computing experience and they aren't worried about mobility, those systems will still sell. But they aren't necessarily going to be the most exciting looking system to someone who sees these things all the time, but they'd be good enough for someone who just wants to get online and do their emails and maybe a few other activities, right? In actual fact, we have a lineup of 4 machines over there which we spec together for gaming systems at different budgets. And the first budget being £350, which guess what? It's the same price as the 2 the refreshed consoles, right?
Yeah.
So if you're going, oh, do I refresh my console or do I go down the PC route, save a bit of money on all the games? You know, where do you start? So and then you've got a bit more money. You know, what do you get with the extra increments? So we've put together 4 sort of specs over there, ranging from £350 to 2,000.
Oh, please.
Okay, so yeah, we'll cover that a bit later. So I was originally supposed to do a talk on overclocking at this point, but you've asked me a bunch of interesting questions, and I just like people throwing questions at me, and I'm just talking definitely. So do you want to see anything about the overclocking side? No.
I actually had one more question. I can remember back in the day when we had to actually worry about front side bus on motherboards, back when we had the North Bridge and everything. And up until a few years ago I still had a 133 megahertz computer to mess around with. But obviously that's gone away, and we've got that now on the chip. And we're starting to move further into things like embedded chips in the motherboards. I just want your opinion on whether you think kind of this modular style of systems and computing will still be there 5-10 years down the line, or whether the things like the CPU and maybe even the RAM will start to become even more involved in kind of central board, such as, you know, embedded RAM.
Sure,
in
okay.
The motherboard.
That's an interesting question. I really don't know the outcome of this. As far as
I just wanted to speculate.
I'm aware, this modular approach is essential for a large market, and you know, it's a way of and therefore it sort of meets that market need, and therefore it will keep going. You know, it's as simple. If something doesn't meet the market need, it gets changed, or it sort of dies, doesn't it? So it's sort of.
So do you think there will be kind of a almost like a separation between designing systems and PCs for size? So we'll have like the embedded kind of almost laptop to tablet style desktops like the Nooks, and that will kind of develop its own path, as well as this kind of system still staying there.
I think it already has.
10 years down the line. So do you think this will still be here in the future, this style of
this style of expandable system? I honestly, I can't speculate on that. I know you're trying to push you for an answer, but I don't know. Yeah, but I can't really give my personal opinion, I'm afraid. I say, if there's a market need for it, it will continue to be there. It's just economics.
I'm not really fussed, it's just whether it is here in the future. It's just fun to be able to take things out and mess around with them.
Another question.
Don't worry, it's not a big one. Just out of curiosity, do you think Moore's law was like an accurate prediction or a self-fulfilling prophecy?
That's an interesting question, one I don't really have an answer for. As far as I know, it was based on some real research, because Dr. Gordon Moore was a leader in semiconductor technology, and that's a prediction that he came up with. It's like a rule of thumb, right? Not everything. What we are hitting is quantum physics. So go and play with some chaos theory, and you end up with a chip, right? So yeah, I don't know. It's a very complex thing.
We'll preface that right now, and we say this pretty much every single time people ask, is the end of Moore's law coming? We say we have a roadmap X number of years, and we see it fine. Another 5-10 years from now, we'll say the same thing. So it does change. There is a level of economics, and of course, the line of physics we have to kind of consider as well. But as of right now, it's alive, healthy, kicking.
Thank you.
Good. Right. Hello. Flash again. talk about overclocking. No more questions, so. But yeah, realistically, overclocking by its nature and the way it works is you are stressing the silicon beyond its design boundaries. Now that's part of the fun, obviously, to see how much you can get out of it. When the systems are tested, we guarantee them to last a certain length of time, we guarantee them to work at that frequency, and that if you leave your system at stock speeds, it should work flawlessly, right? But when you start tweaking it, you get some weird sort of things going on there, and Intel basically doesn't guarantee anything that happens to your processor after you do that. Likewise, the other component manufacturers have a similar policy, but obviously I'm talking about Intel here. So that was it for the PowerPoint, and the rest goes back to, if I can do a nice, we've got this nice sort of whiteboard that's green. How do we get the other input in there? So that one is, and then you hit OK. I think, yes, it works. See, and there's my technical pen. So, overclocking. How does it work? So, who's had experience with what platforms? Which platforms, I should say?
I guess both really, haven't we? That experience, you know, with AMD and Intel platforms. I mean, obviously AMD a bit more behind. You still have to change other frequencies to get the CPU to overclock, where Intel is more straightforward, especially with utilities to overclock on actual Windows itself and in the BIOS. So.
Okay, but in terms of generation of processor, do you know which ones?
I've not had the luxury of being able to comfortably overclock the recent generations, but back with socket 478 Pentiums and
Okay, you go back a long time.
Athlon, whatever it was.
Okay, great. So you're aware of the North Bridge, and as you were saying earlier, the sort of Sandy Bridge generation onwards, you familiar with?
25, 27 UKs.
Okay, so I use that as a starting point. So I go right back to 478. We might be here another hour. I use this as my starting point. So essentially, what we did with, as you say, with the processors from the sort of what we call second generation core, that's the marketing name for it, Sandy Bridge you would know it as, that family onwards, was we had integrated, obviously, the graphics, that's part of the CPU die, but also we have the level 3 cache, which was already on previous generations, a memory controller as well, again on previous generations. But the main difference was the way that the bus is interlinked with each other. So you're probably familiar, if you tried overclocking the bus frequency of these parts, suddenly you just found the whole machine just crashed for no apparent reason, right? That's because everything was interdependently linked. So if you just give a bus, say, an extra 1 megahertz or something, you might get away with it. But if you give it another 5 megahertz, you then basically screwed up your SATA timings and your PCI Express timings and everything else. So all the rest of the platform was basically tied to that frequency. So the only way you could really safely overclock these generations of processors was to just use the multiplier. So Intel produced what we call the K SKUs. And these were, instead of just having the Extreme Edition SKU, which was $1,000 at the time, it gave a lower entry point into an overclockable CPU. Okay, and so we had the 2600K, which I'm sure many people still use today fondly, and we sort of went beyond that with the third generation processor, and then we took some of the timing dependencies away. Now, I think it's Z97, we've now given more flexibility to overclock the bus. That's one of the main features of the new chipset. This is why you needed the new chipset to work with the two new K processors for the overclocking flexibility. So I know a lot of users just think we do it to annoy them, but there are real engineering reasons why we keep changing the chipset and we add new features, okay? And that's the reason why. So we get a better experience at the other end. Because what we don't want to happen is, you know, say, oh yeah, it'll work on this board, and then you plug it in and go, oh, it's rubbish. I just spent all this money on it and it doesn't work properly. And it was because for this exact reason why we do these socket changes and everything else like that, to make sure that the platform keeps up with the processor, okay? So we've got the end user's best interest at heart, but we might not think it at the time. Okay, so, you talked about 4th generation processor, or as well as you probably refer to it as. This one works a little bit differently. There was one other thing we added with the 2nd generation core, but it was a little subtle change. We added a processor inside it, which actually looked at the power consumption the system used. So the turbo frequency would change depending on how much power the CPU is using. Now, most people never really hit the TDP limit on the processor, so probably were never really limited by the amount of power that they were drawing. Okay, so you can leave it defaults and it probably overclocked just fine. As we went up through the families though, you'll find that power dependency becomes a lot, the dependence on the amount of power you give the system to your overclock suddenly affects the amount and the sort of the length of time you can run at a particular frequency. Alright, Kieran. So, what does this mean then? So if you're used to overclocking before, generally you do a simple thing. To get high frequency, you shove more volts into the processor. You know, that was the simple way of overclocking. Oh, let's give it more V-core. Yeah, 1.5 volts, that'd be alright. Remember the old Solarons with 2.1 volts. Sounds ridiculous now, doesn't it? But that was the sort of old way of doing it. With the new processors, they're a bit more subtle than that. Bear in mind the conversation we had earlier when we were talking about how we've designed the processors to be more able to be working in a smaller system, so therefore they use less power. So power becomes a very important factor into the clock speed of the processor, because a lot of them are limited by their power envelope. And that's where turbo comes in. So turbo takes advantage of the power envelope at any one time. Okay. With the desktop processors, they're essentially the same architecture. Obviously, the power envelope we give them out the box is a lot bigger. So the new processors are 88 watts. The previous generation, well, not generation, but the previous overclocked, the K SKU was 84 watts, okay? So we give it 4 watts. What's that 4 watts do? Well, it allows it to run up to 4.4 gigahertz without any intervention. So that's its, 4 gigahertz is its stock. This is the i7, the 4790K. So this allows the processor to run to 4.4 with a single thread, or 4.1 on all 4 threads. And it's got a 4 gig base clock. So let me just write something down. Who knows? Do you reckon Ohm's law? Okay, quite simple. Okay, well, we take resistance out there, okay? If you sit there, and there's another thing as well, watts equals V. Right, okay, so volts times amps equals watts. If you pull too much power from your processor, obviously it heats up because it has a resistance, right? So we know that. But now, where am I going with this? Question.
P equals V squared over R, so voltage doubles power.
Thanks, Dana. You can't do this.
I just thinking about it in my head.
Yeah, exactly. So, as Anna just mentioned, if you increase a little bit of a voltage or a little bit of a current, suddenly the amount of difference it makes to the power draw is huge. Okay? So if you're in a constrained power environment, then actually sometimes, it may sound ridiculous, undervolting your processor will sometimes give you more performance than increasing the voltage. Actually, increasing voltage normally limits the performance even more and tanks it. So if you just sit there and sometimes undervolt it, leave it at stock speeds, you'll find it with turbo at its higher frequencies for longer, and sometimes outperform it when you've purposely gone and overclocked it. So that's one aspect to look at. Something else as well is the way the heat is dissipated. So you're probably familiar with what these processors look like. You're obviously use YouTube. You probably look at what others have put, delidding their various processors and things like that. That definitely validates a warranty. So, what is in a desktop processor? So there's a green substrate, always green so far anyway, and then there's a die which is actually upside down, and on top of that is a metal sort of cover called the integrated heat spreader, IHS, and between the top of the die and the sort of inside of the integrated heat spreader is some thermal paste. Okay, thermal interface material. Now, there was a lot of noise in the press about our 4th generation processor having bad thermal interface material. Well, it wasn't bad. It met the specifications that Intel guaranteed the processor to run at. So, what was wrong with that? It was just, okay, if you're running the processor out of spec, e.g. overclocking it, then maybe you ran into some difficulties. As I said, we don't guarantee the overclocking, but we did listen to our enthusiast community and say, okay, well, if you really want an overclockable CPU, we'll give you one. But we won't just improve the thermal interface material and give you the same processor back. We're actually making it different in other ways and improve its power, delivery and other aspects like that. So you actually see some differences on the new K SKUs compared to the previous K SKUs. Simply to, we looked at all the aspects. Being a bunch of engineers, we looked at everything that a processor does when it's overclocked, right? Including increasing TDP a little bit. So going back to this formula, there's something else that happens as well. Temperature. So one of the other factors which throttles the processor back is how hot it is. Now, I know, again, temperature is an obsession with enthusiast users. It's got to be under 50 degrees. To be fair, any of our modern processors under 85 are absolutely fine. Now, once you go over 85 degrees Celsius, you start running into an issue where it actually starts drawing more power. So the hotter a piece of silicon gets, the less sort of insulating it becomes, if you like, and it starts actually drawing more power. You actually get more leakage current. So therefore, the current increases all by itself, and therefore your power consumption increases all by itself. You can actually watch that. If you sit there and allow a processor to get really hot, but you run it at the same frequency, you will actually see the amount of power draw it has increases over time as it gets hotter. So what does this all mean? So you've got to keep your processor cool, but under 85 is fine. You don't always get the best performance by giving it lots of volts, because that makes it really hot. So then it starts throttling back that way, or it hits its power wall. Okay. Now, what can you do about the power wall? Well, if you're on a desktop machine, you can most likely increase the amount of, so there'll be a couple of settings you can change, and that will be you increase the overall turbo power, so that's the maximum instantaneous power it takes, or you increase and also increase the long-term turbo power, which is how long it, what it would run for indefinitely at, but also the current. So you might need to increase the current you're giving the processor. Now inevitably, this will all just create more heat. Now you might find that your cooling solution is great and it doesn't get over the magic 85 and it stays way under it. So then you can try playing a bit more voltage, okay? But you might find it just heats up straight away and hits 92 degrees and starts going mad and throws itself right back. So what do you do then? You then actually start reducing the voltage. And try clamping the amount of current as well. So you might actually limit the current it has. So it sounds counterintuitive to how you may have overclocked previously, where it's just a case of shoving more volts in the processor and seeing how far the clock went. Because all these mechanisms in there, as I said, it makes the overclocking interesting. So it's a bit more of a challenge, right? So getting a good overclock. Bear in mind, it's not just desktop systems you can overclock. You can overclock mini systems, you can overclock laptops. Philippe's just holding one that overclocks quite well. But you'll often find these are clamped, so they have a power limits already set in them. The only thing you can then do is reduce the voltage and see whether your turbo will run longer. Because you'll find if you hammer all the cores, it will never run at full turbo for more than a few minutes. Okay, does that make sense?
Yeah.
In this counterintuitive way. So there you go, when you overcome 4th gen, try reducing the voltage. But, so we're going to have the motherboard vendors, a couple of representatives from them come in and they'll show you the tweaks and tricks on their motherboards here. I've got a couple of benchmarks on there, also Prime 95 sat on there if you want to try cooking them. As you see, they got different heatsink solutions on, simply because I didn't have 6 H100s, and the second one I had decided to leak, so there you go. That's because it's been sat in a cupboard for a year.
So, I think a quick introduction here. So we have Gareth from Asus and Andrew from Gigabyte already in the room here. So please pick these guys' brains while we have them. We have some boards that they've graciously provided for this event here, and they are running on our newest Devil Canyon CPUs. So you guys are some of the first guys to actually be able to play with them since they're not available in retail yet. So yay. And then we also have some Devil's Canyon and a couple of other Haswell-based or 4th generation based products on this side. And these are manned by Simon and team here. We will also have a bunch of laptops, ultrabooks, tablets. If you guys just want to give it a go, all of course Intel based. We just really wanted to show you some other things that you can game on that your viewers and readers might be interested in. So we'll have that set up here. Coffee, tea, food, please help yourself whenever. And just let us know if you need anything else from us in regards to Wi-Fi, restrooms, smoke, whatever. We're here at your service. Okay? So feel free to dig in, start at any of these stations really. The idea is you guys can just start rotating as you need to film and take what you want while you're here.
Yeah, no, what?